In this note, we're going to be analyzing distance and time graphs and looking for specific pieces of information. So just to recall, by looking at a distance time graph, the things that we can determine about speed, or the speed of an object, is that if we have a steep line, means we're moving fast, a shallow line means slow, a flat line means zero speed or stopped. Talked about straight lines. Straight line meaning constant speed. And curved lines or nonlinear lines means not constant. So that's what we should have learned in the last two notes and from the homework, these kind of descriptions about a distance time graph. Now, what we're going to look at today is we're going to look specifically at speed. So when we talk about speed, we don't just refer to it as fast, slow, stopped. Right? When we talk about speed, usually there's some units involved that gives us an actual description of how fast we're going. If you think of a car, the speedometer does not just say stopped, slow, fast. It gives us an actual speed, or like kilometers per hour. So that's what we're going to be looking at today. So just to recall, the formula for speed or velocity is speed is equal to distance divided by time. So this may be something that you've seen in science class. We're going to look at it today. So speed equals distance divided by time, and you can determine the distance traveled of a segment. So if I look at each section of a distance time graph, I can figure out how much distance is traveled by looking at the change in y values. Remember, distance is the vertical values, so I'm looking at how much it's changing in my over my segment. I can determine the time of a segment by looking at the change in x values. So again, the x-axis refers to time, so I can see how much time is passing or changing by looking at the change in x values for my segment. So on a graph, the speed is also known as the slope. We have talked about this before, in other words, the steepness, and it can also be referred to the rate of change, or how much something is changing. And you can kind of get that because we're looking at how do the y values change and how do the x values change. So in example 1, Chris runs every day as part of his daily exercise, and the graph shows his distance from home as he runs his route. So we have our distance time graph here. We have our vertical axis of distance. Each box is representing 200 meters, so 200 for, we'll say 600, 8,000, 1,200, 1,400, and so on. And then on our horizontal axis, we have our time in minutes, which each box representing 1 minute. So I want to complete this chart for his run. So if I'm looking at the first section, which would be A to B, or AB, the direction that he is traveling away because the line is going up, and the distance traveled is, if we look at A, it starts at 0 and goes to 200, so that means he's traveled 200 meters. If I look at the time, he starts at 0, he ends at 5, so he's traveled for 5 minutes. If I want to find the rate of change or speed, I can do 200 divided by 5, or my distance divided by time, and I get 40 meters per minute. For my next section, B to C, Again, the direction is away because the line is going up, and the distance traveled now is, if I look at my section, I start at 200 and I end at 1,000. So that means that it is a distance traveled of 800 meters. The biggest mistake that people will make is that they just look at the end and say, oh, well, he ends at 1,000, so that's how far he traveled. You have to keep in mind we're only looking at this section from B to C, so I need to look at where he starts and where he finishes. While he does finish at 1,000, he only starts at 200, so that means the total distance traveled is 800 meters. The time, again, if it ends at 10, but he starts at 5, that means this segment is 5 minutes long. So again, we're not looking at how much time is taken for the end. We're looking at it in terms of when we started. So while we finish 10 minutes into his journey, this segment only starts at 5. So 5 to 10 means there's a time of 5 minutes. To find the speed, 800 divided by 5 works out to 160 meters per minute for our speed. For the next section, CD, here again the line is going up, so he's moving away, or his direction is away. And if we want to look at the speed, or the distance, again we're starting at 1,000, we're ending at 1,400. So that means it's a distance of 400 meters. For time, we're starting at 10 minutes, we're finishing at 15. So it's a time of 5 minutes again. To find the speed, 400 divided by 5 equals 80 meters per minute. So that is his speed for that section. For my next section, D to E, this one is an easy one. Because it's a flat horizontal line, the direction is stopped. The distance traveled, we start at 1,400, we end at 1,400. So that means we have traveled a distance of 0 meters. The time, we start at 15, we end at 20. So that is a time of 5 minutes for that section. Our rate of change, or speed, 0 meters divided by 5 minutes. But we know that if we're stopped, our speed has to be 0 meters per minute. And then finally, the last section, E to F. Our direction is towards, because the line is now down, so we're running towards our reference point, or in this case, we're running home. Our distance, we're at 1,400 and we go to 0. So it's a distance traveled of negative 1,400 meters. Our time goes from 20 to 25. So that means it is a distance or a time of 5 minutes. So our rate of change now, negative 1,400 divided by 5 works out to 280 meters per minute. So that is finding the time, or the time, distance, direction, and speed for each section of Chris's run. How long did it take Chris to run his route? We could add up the time of each section, or we could look at, well, he starts at 0, and where's the last point, or where does the last section end? It ends at 25. So it takes him 25 minutes to run. How long did he stop for? Was only one section where he was stopped, and it was for 5 minutes. How long would the trip have been if Chris hadn't stopped? Well, if we assume we just take out that section, that means we take out 5 minutes. So 25 minus 5 equals 20 minutes. So we could assume that his trip would take 20 minutes. Number 5, can we have a negative speed? What does the negative speed symbolize on a distance time graph? Well, we can't have a negative speed. If you look at a car speedometer again, you're not going to see negative kilometers per hour on there. It goes from 0 to say 300 or 200 kilometers an hour. You're not going to see the negative on there. So you can't have a negative speed. So you can't have a negative speed. However, if we look back at our table, we can see that our last speed is negative. It is negative 280 meters per minute. So we have a negative speed there, but we've just said that we can't have a negative speed. So what does that negative speed symbolize on a distance time graph? And what it symbolizes is the direction. So the negative symbolizes traveling towards. Because again, that negative meant we were traveling back, or that line was going down, so we were traveling towards something. So if you see a negative speed, it's most likely indicating that we're traveling towards. Example 2, we have another distance time graph between two runners. So the first question is, who got a head start? In this case, it was runner B got a head start, and we can see that by looking at time 0, and we see that runner B is ahead of runner A. So that means that runner B got a head start. Who is the faster runner, and how much faster are they? Well, just by looking at the graph, we know speed is indicated by the steepness or the slope of the line, and we can see that runner A has a steeper line. So right off the bat, we can say runner A is faster. But we want to know how much faster is runner A. So let's look at each section and figure out the speed. Runner A, we'll do in red, traveled from 40 meters to 0. So you could say they traveled negative 40 meters for that section, and it took them 4 seconds. So we're looking at negative 10 meters per second. But again, the negative is only indicating direction in this case. Runner B went from 30 to 10, so they traveled negative 20 meters in 4 seconds, or we traveled towards for 20 meters in 4 seconds. So we're looking at a speed of negative 5 meters per second. The negative again is only indicating that we're traveling towards. So that means that again, runner A is faster, and how much faster? Well, 5 meters per second. Who won the race, and how do you know? For our next question, well, runner A has won the race. And we can tell because they reach the 0, or they get back to the reference point before runner B. So you could say runner B reaches a 0 distance before runner B. Where do the two lines cross, and what does this point mean? Well, we can see that runner B and runner A, their lines cross at this point here, which is 2 and 20. So what does this point mean? Or where do they cross? Well, they cross at 2 and 20. And what does this mean? It means that the runners pass each other at 20 meters. Or you could say they pass each other after 2 seconds. Or you could say they are in the same spot. Because again, at that split second, they are both 20 meters from the finish line at 2 seconds. So the key thing from this note is just understanding how to calculate speed from a distance time graph. remember to avoid the common mistakes of just looking at the end values of each section. You want to be able to, again, recognize how long is each section, not just what is the end value.